Divide 6x cubed minus 8x squared minus 14x plus 13 by the binomial x plus 2. So we'll start with x plus 2 on the outside as our divisor. And then on the inside, for the dividend, we must make sure that we're not missing any placeholders or any powers of x. So we start with the highest. We say 6x cubed minus 8x squared minus 14x plus 13. And since I wasn't missing any powers of x, I didn't need any zero placeholders. Now, similar to the way we do long division in arithmetic, I am going to take these two terms and divide them into these two terms. But what's more specific than arithmetic is I need to know exactly x times what would give me 6x cubed, and that would be 6x squared. So I'm going to go ahead and line it up in my x squared column. So 6x squared. We have a nice check in algebra as well, because when I multiply it back through, this first term must match. So 6x squared times x is 6x cubed, and then 6x squared times a positive 2 is a positive 12x squared. Now, a common mistake is to add these, but just like in arithmetic, you have already placed these evenly somewhere, and so you need to take them away and see what's left to be divided out. So I need to distribute a negative. So I'll distribute this negative throughout my problem. So the first term must go away, and then the second term becomes negative 20x squared. And similar to arithmetic, I just bring down the next one place, or in this case, the next one term, because I have two terms dividing into two terms. So we start the process again. X times what would give me exactly negative 20x squared? Well, that would be negative 20x. We have a check here because it should line up in the same value of x, or power of x. Multiplying it back through, you should get exactly this first term. So you have a couple checks going on in here. And then negative 20 times a positive 2 is a negative 40x. And once again, we needed to subtract these values, not add them, just as in long division. So I'm going to distribute this through my binomial. The first term must go away. The second term becomes 26x. And finally, I'll bring down my last term, knowing that this is the last part of the division, and anything left over will be a remainder. So x times what would give me exactly 26x? It would be a positive 26. Once again, noticing that this column has no x's, or x to the 0 power. So 26 times x is 26x, and 26 times 2 is a positive 52. And finally, I am subtracting these, so I'll go ahead and distribute that sign. The first term must cancel, and the second term becomes negative 39. So this is my remainder. I'm going to write my remainder as a subtracted 39 out of x plus 2. And because we have a remainder, it means that x plus 2 is not a factor of this polynomial.